systems of equations. Last week, when we were working with systems, we were primarily graphing them. Who remembers what is a system of equations? You did write a definition down, but you worked with them for a few days now, so what do we recall? Oh, sorry, I thought you had your hand up. What is a system? If I said, here's a system, what are you looking? Go ahead, Zach.
Two or more related linear equations for which you are trying to find the common solution.
Two or more related equations that we're trying to find the common solution. Last week, when we were graphing them, what did the solution look like? What did the solution of the systems look like? It was a point. What point?
The point where they cross?
Yeah, it was the point where they crossed. If I graphed a system, I had one line like this and one line like that. This point here is their solution. What does it mean to be the solution of a system? What does it represent?
The point where they intersect.
And what does that mean in terms of the equation?
Yeah, I don't know. They're
At this point, what do I know about that coordinate? That x and that y.
I would say
That's the only x and the only y that what?
me.
That solves both equations. Absolutely, yeah. It's the only x and the only y that are on both lines, which means they solve both equations. So now we did that last week. There are some scenarios where it may not be beneficial to graph. I'm sorry, just silence it. Like this one. Let's take a look at this system. Okay, now we're looking at it as a riddle. Sienna wrote a riddle, but let's just look at it as a system. If I wanted to graph this to find the solution, how would I graph this top line?
oh, you have to put negative 20 on the line.
Yeah, so my y-intercept would be all the way down here at negative 20, and what's my slope? 1. So it would look something like that. How about the second line, x plus y equals 84? Where would that graph?
On the y.
Where on the y-axis would a
All the
coordinate
way
be?
up?
All the way up at 84. And then what would the slope be for that?
Wow.
If I had to get y by itself, what's my slope?
84 over 1, right?
It would be negative x plus 84. So what's my slope if I rewrote this equation? Negative 1, so it would go down. But here's the problem. Is it going to be easy for me to plot a graph all the way up at 84 and then the other one all the way down to negative 20? Probably not. So there are other ways that we solve a system.
You simplify it.
And we're going to use this riddle to help us out. So Sienna wrote these two equations to help solve a riddle. We have y equals x minus 20 and x plus y equals 84. We are trying to find the value for x and the value for y that work for both equations. There's only one x and one y that work for both, and we want to find it. What does this equation mean in terms of y and x? What do we know about y and what do we know about x based on just that top equation? What do I know about y? Now, we're not talking about the line. We're actually talking about the value of y. What's the only piece of information that I'm given based on that equation?
That y is bigger than 20. Because of, wait, I don't know how to say it.
Is y bigger than 20?
Wouldn't it be? No.
That they're equal.
Yeah. Well, yeah, that 20. I don't know what to say. That when you do
Y
something
is what?
equal to x subtract 20.
Okay, so y is equal to x minus 20. So y has the same, what do I know about y? Y is what? Is
Solution.
Equivalent to that?
The solution is when you do something.
Y is, yeah.
well, we're not talking solution yet, and I don't want to trip you up here, but we need to figure out some way of explaining the value of that variable. Right, so if I look at that equation is y equals x minus 20. What does that equation tell me about the value for y? No matter what x is, what would y be?
Minus
20 less than x. No matter what x is, y is 20 less than that, right?
20. Yeah.
So if x is 100, what's y? 8. Yeah, if x is 300, what's y? 280. Good. How about this equation? What do I know about the relationship between x and y based on just that equation? No matter what x and y are, what do I know? They have to add up to equal 84. Exactly. So now I need to find a value here where I have to find an x and y where y has to be 20 less than x, but also if I add those two numbers together, they have to equal 84 because my x and my y have to satisfy both equations. Could we guess and check?
Yeah.
Sure. Let's try x for 44 and y for 40. If x is 44 and y is 40, does this work for both equations? If x is 44 and y is 40, does it work for both equations? Does it work for any of the equations?
One.
Which one?
The bottom.
The bottom one. If x is 44, 44 plus 40 does equal 84. But does 44 minus 20 equal 40?
No.
No, that's a problem. Can't be 44 and 40. Let's try 50. If x is 50, what is y in this equation?
30.
30. Okay, so that one, if x is 50 and y is 30 would work. What about here, if x is 50 and y is 30? No. Still no. Okay. Try if x is 52. If x is 52, what's y? 32. Okay, so that works here. Does it work here? If x is 52, y is 32. Does 52 plus 32 give me equal? Yes. What did we just find? We found the solution to the system. The solution to the system is when x is 52 and y is 32. Now, what does it look like on a graph? What does the 52 and the 32 represent?
Coordinate.
The coordinate, yeah. So you can represent this answer one of two ways. The goal, as we solve algebraically, is for you to remember that you're actually finding a coordinate. So you're finding an x value and a y value.
Is that why we use X and Y?
Typically. We will go into some real-world examples on Friday where we don't use x and y, but it's still the same concept. You're finding the coordinate. Does guessing and checking work all the time?
No.
What's the problem with guessing and checking?
You have like a million
Yeah, it
pages.
can keep you guessing.
Yeah, it could just take a long time, right? It could take a while. So we do have an option to graph, but the equations that we just worked with would be a bear to graph, right? So we need another way. Substitution is one of those ways. So just write down the word substitution, because that's what we're focusing on today. And as you write that word down, what do you think about when you hear the word substitution?
Sub.
You think about a sub. What do you mean a sub?
Like a teacher.
A substitute teacher. That's a really good example. What is the role of a substitute teacher? A substitute teacher replaces the primary teacher if we can't be here for whatever reason. So a substitute teacher is one that replaces me if I can't be here. So when we think about the word substitute, what do you think we're going to do? We're going to replace something. Absolutely. We are going to replace a value. So now let's take a look at the two equations. We already know the answer, but I want you for a minute to pretend like we don't know the answer. Is there any value for a variable that we are given in these two equations? Do I know x is this or y is this? Based on those two equations. And this is a good example to write down. So write down those two equations so as we go through the example, you can keep those notes in your notebook. Do I know any of the values for x or y? X is this or y is this?
Not really.
Now when I say value, I'm not talking about a specific number. Right? We're not going to know if x is 3. Not yet. But do we know anything about y or anything about x?
We know that they have to equal 84.
So we know that the two of them combined would equal 84. Good. And what about the top equation?
You know that y will be
Less than,
yeah,
20 less than X.
Good. So I know that the value of y is the same as x minus 20. I know that they're the same. Okay. So take a look at that top equation and think back to Unit 1. When we were solving equations, did we solve equations that looked like that?
Yeah. Well, no, the Y, like, usually it wasn't like that. It It'll be
Take a
like
look at the second equation. Did we solve equations like that in Unit 1? Why not? What was different? You could look above the smartboard to the anchor chart. What was the difference between the equations in Unit 1 and the equations that you see in front of you now?
Well, why would have like a value? Like it'd be like something like 60 equals 80 subtract. Well, x subtract 20. You know?
Exactly. So what are you seeing now that we didn't have before?
Well, the x and y don't have numbers.
So there's two unknowns, right? This is the problem. There's two unknowns. Based on the skill set that we have right now, how many unknowns can we solve for? One. So is there a way that I could replace something in one of those equations that would turn the equation into one with only one variable instead of two? Now here's, when I talk about replacing, we have to make sure that we're not changing the value. So I want to substitute something in so that the value of the equation doesn't change. Is there anything that I can replace? Now the top equation tells me that the value of y is the same thing as x minus 20. So could I replace a y? If I already know that it has the same value as x minus 20. Where could I substitute? Take a look and see if you could substitute something so that either equation ends up having only one variable. What do you mean divide by x? If I divide by x, I'd still have an x in as the divisor. So dividing by x wouldn't get rid of the x. Is there anything I could do to get rid of a y? Think about what we're doing here. We're learning about substitution.
Substitute 0.
But then I would be changing the value. What does the top equation tell me?
Not y equals 20 less.
Which means y, the value for just a y, is the same thing as x minus 20. So do I need y's anymore, or can I just replace them? I can replace my y with what? With what?
With 8.
Without changing the value, what can I replace every y that I see with? What's the only thing I know that equals y?
X minus.
So is it possible, if I know that y has the same value as x minus 20, can I just replace every y with an x minus 20 since they have the same value?
Yeah.
So could I just replace this y with x minus 20? Did I change the value of the equation in any way? No, because y and x minus 20 have the same value. Alex, face forward, please. Looking at him is not helping, right? So y and x minus 20 have the same value. So are these two equations different in terms of their value? No. Which one can I solve? The top one or the bottom one? The bottom one, we already have a skill set to solve. How would I solve that bottom equation?
I mean, this should.
How do I solve this equation? 2x minus 20
Equals 84.
Now what?
Now subtract plus 20.
Add 20. So 2x equals 104.
Yeah. Now divide by 2.
Divide by 2. So what's x?
52.
X is 52. Am I done? Did I find the coordinate?
No.
No, because I only have which value? I only have x. What's y? What should I do to find y?
Plug in.
Yeah. Does it matter which equation? No. If I plug in 52 in both, either one, I can do both. What does y have to be?
32.
So for those of you that want to write down the example, this would be here. Now notice what we did. We were looking for a value for one of the variables so that I can substitute it out. The goal here is that I need one of those equations to be written only with one variable because I can solve an equation that has only x's or only y's. If there's an x and a y, that's a problem. So what I know based on this top equation is that the variable y has the same value as x minus 20. So anywhere I see a y, I'm really looking at an x minus 20. So I don't need to work with both variables anymore. I can just take this y and rewrite it as x minus 20, and the rest of the equation stays. I'll actually do it in a different color. When you're learning about systems this way, different colors are really nice because it makes it nice and clear. Once the equation is in that format, I have not changed the value in any way, but I rewrote the equation so that I can solve it. Once I solve it, I can combine my like terms. This part here is all the recap of Unit 1. Which is why, if you need work on stuff from Unit 1, now is the time it comes back. So we want to make sure we're getting that practice in. Now, if at any point in time you're struggling with this idea, think back to the word. This is called substitution for a reason. You're going to replace something. There's another form of solving systems called elimination, which we're going to learn on Wednesday. Think about what you would do there. If substitution is replacing, elimination would be what? Getting rid of something, exactly. But the question here is, what are we substituting? So how did we know? Why do you think the variable y was the one we substituted for? What is it based on these two equations that made y the variable we wanted to substitute instead of x? Because I can substitute for x. What do you think it is about those two equations that made y the desirable variable to substitute? We already know its value, right? We already know that y is the same thing as x minus 20. Y is already by itself. Today, when we're practicing substitution, some of your equations are already going to have a variable alone. Tomorrow, we're going to take it a step further. You might have to do something to get one of your variables isolated. But the idea here is that you're substituting so that our equations go from 2 variables to 1. Now, for those of you that wanted this example written down, do you have it written down?
Yes.
Okay, we're going to try one. Are you ready to try one? On your own. For those of you that are visual, a visual works here, especially if you're trying to figure out what to replace, because you're physically replacing something. I'll show you a model after you do the next example of what I mean by that, so that you can see really straightforward what you're going to replace. So take a look here at this example. You're going to take 3 minutes, and I'd like for you to work on this with the people around you. A couple questions I want you to answer. Okay. First, model this. If you want to model with an equation, you can. If you have a visual, that works too. Is there a variable that you can substitute for? What variable is it? What does the equation become when you substitute the value in, and can you solve it? Take 3 minutes. If you have ideas, bounce them off of each other, because eventually towards the end of class, you're going to be doing these independently. Each layer, we're going to take assistance away. This one is full group. Work together on this 3 minutes. Then we'll do some practice where you're working just with the people around you. And then we're going to do independent to make sure by the end of class that you can all substitute and solve. So take about 3 minutes. I'm actually going to leave the recording on because the follow-up to this, I want to show that if any of you go back to watch it, you can see the visual. Okay, so right now, work together on figuring out what could you substitute. Use the example that you have from that we went over as a group because it's going to help Is there any value? No, it's not that. Do we know what y is? Now, when I say, do we know what x is or y, I don't mean a number. I want to know what that is. What do I know about the value of y or the value of x? Okay, I know that x is y. Okay. Do I know anything specific about the value of y? Y equals what? What does this equation say? Y equals okay, so I know y is the same value. So what is that? What can I replace? I can replace all my y's with what? What do y over here? 5 plus 3 x plus 2. Okay, so over there. Can I rewrite this and replace my y? Yes. Yep. And now you can solve that. Because the bigger equation only have one variable.
I said y.
So we can replace y with y.
Would you replace it? You can solve it. What'd you replace? Oh, so okay, so if you do that, then you're doing an element of guessing and checking. Okay, which is not the worst thing, as long as you understand that you're looking for a value. But if you had to replace the equation, what? Oh no, I know I was wrong. You're correct. But how are you substituting? Like, are you substituting a value for the variable and rewriting the equation, or are you just a process of elimination? X would have to be 1. Okay, let's take a look at these two equations. This is a system, which means they're related. There's an x value and a y value that is shared between both. Okay. So when we talk about substitution, we're talking about finding a value for one of the variables. Now, when I say a value, I'm not talking about a number, just something that it's equivalent to, so that we can replace and substitute. Because the goal is, we have two equations here that have two variables each. Red flag. I want to have an equation that I can solve. So I need to somehow rewrite one of these equations so that it has only one variable. Based on those two equations, do I know anything specific about one of the variables? And its value.
Oh, I know
What do you know?
Well,
Do we know anything specific about the value of one of the variables?
y is 3x times the number plus 2.
3.
That.
So y, the variable y, has the same value as 3x plus 2.
Yeah.
So what can I do?
I'm gonna tell you.
What can I do? Now that I know that, I know that those two sides of the equation have the same value, right? Y is the same thing as 3x plus 2. Sarai, what can I do?
You gotta replace all the y with 3x plus 2.
I can replace all the y's with 3x plus 2. So here, if I replace this with 3x plus 2,
Yes.
what does my equation become?
It becomes 5x plus 2 equals 7.
It becomes 5x
Plus 2
plus 2
equals 7.
equals 7. And how would I solve that?
Subtract 2.
Subtract 2.
So 5x equals 5. Divide by 5. X equals 1.
Am I done?
No, because you need to find your y.
I already have my x, but I need to find my y. If x is 1, what is y? Y is 5. So you can show your answer one of two ways. That way, or
That way.
that way.
Alright, wait.
So let's,
I got to that part.
we're going to go over a visual right now.
How did you find what y was?
Yeah, that's what
We found it. So once we know the value for x, I can plug it in to either equation to get y. 3 times 1 plus 2 is 5. 2 times 1 is 2, plus 5 gives me 7. So I can take that value. So I'm going to show you a visual really quick. For those of us who are struggling with identifying what to replace.
Oh,
So these are the two equations. I didn't design these to mimic algebra tiles. I was just trying to show shapes. Okay? So you can tell by this picture that my x's are the green rectangles, my y's are the red rectangles, and then the constants are the little squares. So the equation on the left tells me that 2x and a y, 2x and 1y, have a value of 7. And I also know that 1y has a value of 3x plus 2. So I want to replace, I don't want there to be any y's in that equation. So I'm going to replace the y with something of equal value. What's the only other thing I can put in there instead of a y?
3x plus
The 3x plus 2. So by doing that, what do I have now?
5x plus 2.
5x plus 2 equals 7. So if I subtract 2 and subtract 2, what must each x equal? 5x's equal 5. So x equals. Now that's just a visual for you in case you needed to see that we actually do replace something. The most common questions end up being, how do I know what to replace? That's a big one. How do I know in this scenario to replace y? What is it about these two equations that tell me I should probably replace the y?
Because you already have the value of y.
I already have a value for y. And again, I can't stress this enough. When I'm talking about a value for y, I'm not talking about a number. I know one really, really important thing about y based on this equation. I know that y is the same thing as 3 x's and 2 constants, which means I can just take away this y and replace it with the 3 x's and the 2 constants. And what I do when I replace, so y, 3x plus 2. For those of you that need a visual, what I've done is I've just rewritten, I didn't change the value in any way. I just rewrote this equation that has 2 variables to now be represented with only 1 variable. It's the same idea as saying, like, if we're trying to find your age and my age, and our ages equal 50, I'm just saying. But if you know that you're 15 years less than me, then I can just take this and show it as 15 years less. I can do that. Because remember, we don't want to show 2 variables if we don't have to. So that's how we're identifying what to substitute in. And the ultimate goal here, and this is a perfect example, is to go from having 2 variables in this top equation to having only 1 variable, it's an x, that I can now solve for. Once I find that value for x, I'm not done, because the solution for a system is what? It's an x and a y, because it's where they meet, it's a coordinate. Does anyone have specific questions that you want to go over before we practice a few? I'm going to actually pause this.